Welcome to part 3 of the first lesson of chapter 10, the Pythagorean Theorem. On to some applications. It's nice to learn something, but also it's nice to use what we learn to answer some real-life situations or scenarios. So when a picture is not given, it may be a great idea to draw one of our own. A 26-foot ladder is leaning against a building. The foot of the ladder is 7 feet from the base of the building. How high up the building will the ladder reach? One of the first things we like to do in a word problem is read it and see if we understand any part of it. Alright, the question that we're being asked, this is the second thing we do after we read it. How high up the building will the ladder reach? So I want to draw a picture. I want to draw a picture of a building and then a ladder leaning up against it. Buildings are usually straight up and down on ground. So here's my ground, here's my building. I don't know, I can draw like a little house type picture here. And we're going to put a ladder to one side of it. It's going to lean up on top of like the building like that. So there's my ladder. I can make it look more like a ladder by doing this. Okay. So there's my ladder. The ladder is 26 feet long. So in my picture, where do I mark that? How can I mark that? 26-foot long ladder. So the ladder from top to bottom, the top to bottom part of the ladder, that's this, is 26 feet. The foot of the ladder, okay, where's the foot of the ladder? At the top or at the bottom? Well, the feet are touching the ground, so the foot of the ladder is 7 feet from the base of the building. Where's the base of the building? Here. So between these 2 points, we know that that is 7 feet. How high up the building? How high up the building will the ladder reach? So from the bottom of the building to the top of the building, what's missing? We have to assume that the wall and the ground form a 90-degree angle, that the building itself is not leaning. And then we have the shape that's a right triangle. Your right triangle may look a little bit different or similar to mine, but this is what you need to do. We don't know how high up it is. Is the x a leg or a hypotenuse? X is going to be a leg. It's one of the two sides that form your 90-degree angle, which means our hypotenuse is 26. That's letter C. I tried to and I failed. I forgot. I'm going to do this one backwards. I'm going to make A equal the number and B equal the variable. Let's set this up in the Pythagorean Theorem. We're going to do 7 squared plus B squared equals 26 squared. When I say set it up backwards, usually I like to solve the variable in front. It's just easier. This variable is over here. It really, to me, does not make a difference. 7 times itself makes 49. 26 times 26 is 676. We're going to subtract 49 from both sides. To get the b squared by itself, we're still going to subtract just so you see what it looks like when it looks different. B squared equals. Now I'm going to need to borrow. To subtract 9 from 6, I'm going to borrow 10 from the 70 to make this 60 and make that 16. 16 take away 9 makes 7. 60 take away 40 is 20. 600 take away nothing is 600. So our b squared is 627. We're going to square root both sides. The equation that we have is going to have 2 solutions, but only one of them is going to make sense. The square root of 627. Is 627 a perfect square? I don't believe that it is, and spoiler alert, through no fault of our own, I don't think any perfect square is going to divide 627. We would have to do half of that number. 627 divided by 2 is 313, so we'd have to check anything below 289. To save you some time, it's not going to work. So divide it by 289, that's 17 squared. Divide it by 16 squared. Divide it by 15 squared. Divide it by 14 squared. Decimal every time. Divide it by 13 squared. Divided by 12 squared. How about 11 squared? How about 10 squared? How about 9 squared? How about 8 squared? How about 7 squared? How about 6 squared? 5 squared? 4 squared? 3 squared? And my last hope would be a 4. It doesn't divide. It doesn't simplify at all. So this is just our exact answer. This answer is exact. The square root of 627, our unit of measurement is feet. If you wanted to approximate, sometimes your directions may say approximate this answer. When you square root 627, we get a decimal that looks like 25.0, and it depends. If I'm going to round to no decimal places, or sorry, 1 decimal place, I'm just going to say 25.0 feet. You have to put the 0 in there because it shows that it's rounded. If it's 2 decimal places, it would be like 04. If it was 3 decimal places, it would be 0399. So it would be 040. That's good enough. Let's do 3 decimal places and it would be feet. So our last exercise before we summarize today's lesson. Here's another word problem. It's a great idea to draw your own picture. Before we draw, we're going to read and identify what the question is being asked us to answer. From his home, Ian walks 6 blocks north and then 8 blocks east to get to school. If there was a direct path from his home to school, how many fewer blocks would Ian's walk be? So Ian is walking from home. He's walking 6 blocks north. So I'm going to draw a line up, label it with 6. We're going to go north. And we're going to go east. So we're going to go to the right, 8 blocks. North and east are 90 degrees apart. So far we have 2 sides that form a 90-degree angle. Those I can't call legs. I don't have 3 sides. And now he's going to be at school. So first home and school. It says if there were a direct path from his home to the school. So a direct path would be a diagonal line connecting the H and the S. How many fewer blocks will he walk? Right now, his old way, how many blocks does he walk? 6 this way, 8 more, that makes 14 blocks. If there were a direct path, how many fewer blocks would he walk? To make and find this distance, we would have to use Pythagorean Theorem. Are we looking for a leg or a hypotenuse? This side length, that direct path, would be the hypotenuse, a c value. So we're going to set up a squared plus b squared equals c squared. We're going to do 6 squared plus 8 squared equals c squared. 6 times 6 is 36. 8 times 8 is 64. Combine like terms, 100 equals c squared. Square root both sides. Although this equation has 2 answers, only one of them makes sense. The square root of 100 is 10 equals c. This would be equal to 10 blocks. So the new way would be 10 blocks. How many fewer blocks would he walk if there were a direct path? We're going to take the old and subtract the new, and that's going to tell us our difference. So what's 14? Take away 10. The answer is 4. So Ian would use, or would, if there were a direct path, it would be 4 fewer blocks in distance. Let's summarize what we learned today. Today we learned about right triangles. Right triangles have 90-degree angles in them. That is a terrible picture, but you get the idea. As long as it's marked with a square, then it is a right angle. So right angles are formed with a square. Let's try that again. If you have a right angle in a triangle, we have a right triangle. The 2 sides that make up the 90-degree angle, those are legs. We call those A and B. The longest side is called the hypotenuse. We call that C. The Pythagorean theorem used to find any missing side length given the other 2 values is a squared plus b squared equals c squared. The sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. We can use it to find the length of a hypotenuse given the legs, or the length of one of the legs given the other leg and the hypotenuse. Always, 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 we're going to simplify our radicals whenever possible. Sometimes it's not possible. We can use this to answer any sort of word problem. Let's take a look at your homework. Homework is page 5 and 6. The first section, determine if the given lengths form a right triangle. We're going to use our Pythagorean theorem, noting our longest side. If a squared plus b squared equals c squared, then yes, we have a right triangle. If a squared plus b squared doesn't equal c squared, then we do not have a right triangle. Second section, 3 through 10, find the missing side length. So we have legs. Everything in this section looks like we're having legs. We're going to find our hypotenuse. So we're going to set these up one way. On the back, we're given hypotenuse some of the time and a leg. So this would be the other format. Then you'll have to complete 2 word problems. Best of luck to you. Watch these videos multiple times if needed.